Well, hi, and welcome to my shop here on July 10th. Another beautiful, fantastic day. The weather here has just been the best it can be, so I don't want to spend too long in here today. And I'll have an empty bench in front of you because I'm starting a new radio. This will be the first video on it. And you might be a new viewer who's never watched any of my videos. So, lots of words of warning here. First of all, very lightly edited videos. I produce very light editing, mostly correcting some transition problems that occur when I'm making these videos. So essentially, I'm doing this live in front of you, no script, no practice, no nothing. And often the radio I'm working on, it's not the case with this particular one, but often the radio I'm working on I've never seen before. There's 150 million thousand radios out there, and a few of them are making it to my bench, and seldom is it the same one again. But that's not the case today. I have seen this radio. I think I've done certainly 2, maybe even 3 of these. It's a 981. We'll be looking at it in just a minute. So what happens here, because I shoot these live without much preparation, is often at the start of the video I say I'm going to go that way, and within minutes I'm going this way because something is showing up. I make mistakes. Sometimes I misspeak. In my head I've got the word green, but the word red comes out of my mouth. All these weird things happen. So what I say to people watching my videos is put on your thinking caps, pay attention, because things don't always work out. Now, what's underneath the brown paper here? Great big speaker. Okay, let's get the cord out of here right away. It's stuck in there. It might tear the cone. Well, okay, so why am I starting with the speaker? Because it's on top of the box that has the radio in it. That's why. So let's start with the speaker. Many wires, big coil, transformer. That's what's going on with this guy. So this is a speaker that has a field coil in it. This big coil here generates the magnetic pull that's needed to make the speaker operate, but also functions as an important part of the power supply in the radio. In fact, it's part of the filter that's taking the hum out of the radio, a very important part. You can see some mold or mildew on here. So this radio spent some time in moisture, I think. So the small transformer here is basically to match the output impedance of the output to the impedance of the speaker, which is going to be quite low, maybe 8 ohms. I think that's a very common number, but it doesn't necessarily mean this is 8 ohms. It could be something else. Lots of numbers stamped on it. Let's take a look at the paper cone. So radios that are in these big wooden cabinets often have big speakers that are in perfect shape, like this one, because they're absolutely protected, as most speakers are protected. So what I'm looking for are tears, especially tears in this area of the speaker. The speakers, in my experience, is they tend to fail out here first. Now you see a great big crack right here. So we're going to take a close look at it. So this first stage with the radio repair process is really an assessment stage. We're just basically looking things over really closely. So I'm going to switch to a camera I can look more closely at it with, and I'm going to wonder, where the heck is the camera? Where is it? It's this one. Oh, okay, so I had a little bit of trouble with this camera. We'll keep using it here. So there's the crack right there. Now you can leave this if you want. You shouldn't, but you can do that if you want. Looks like there's another crack forming. Maybe not. Right in here. The problem with these cracks is they let air through, and they can act like little flaps. And given the right frequency in the speaker, now this is a seam here. Where'd it go? I looked away for a moment, and sure enough, hey, camera, stay focused. So if you don't heal these, and or fix them in some way, they're going to get bigger, and you might hear various sounds, and it sounds like distortion in that. One crack. You gotta wonder why it would just be one crack. Right here. The repair is really easy. Just a glue-soaked piece of paper towel, basically, laid over top of that. We'll just seal it back up. You don't want air to come through. Now I'm going to give you a little bit of speaker theory here. Again, my expertise is like 80%, and sometimes I talk in the last 20% and I shouldn't. But speakers. Of course we know what speakers do. Speakers push air. But maybe you've noticed that a speaker out of its cabinet doesn't have any bass. So if we played this speaker, we would hear the mid-range and the upper sounds quite easily, but the bass would be missing. Well, where did it go? It's the same speaker. Put it in the cabinet, hear the bass. Take it out, don't hear the bass. The problem is the speaker will short circuit itself sitting here like this. And I don't mean electrically at all. I mean the air. The air will short circuit. When you push the air forward, the added pressure wants to go back around the outside and get behind it. Just like if I just take my hand and move it like this, the air that's in front is going to slip over and go down the back. So how much air can I push if my hand is like this? Well, I can't push very much because it's just leaking over the back. But what if I put a huge board here on my hand? Or my hand was mega hand. I had a huge hand, and now he did that. Hey, that's the principle of having a paddle for your boat, right? The paddle doesn't look like this. It has a flat area on it to push more water. So how do you solve this problem of the air just leaking around to the back? By the way, the higher frequencies can't make it there in time. They can't make it there. So the higher frequencies sound fine, just the low stuff. Well, you baffle the air. So if you put a board, big board, like maybe even, you could even picture a wall. If you had this installed in a wall, so the wall went on essentially for infinity, you could think of it that way, then the front air would never reach the back air. There would be no short circuit, and the bass would be really pronounced, and it would be. But the problem is you can't afford to have walls attached to your speakers. They won't fit in your house. So let's say you make the walls smaller and smaller. Maybe get it down to this size. Well, yeah, you're going to hear more bass, but there'll still be some leaking around the edge. So what if we bend it and send it back here? What if we go all the way and seal it and make a box? What if we put the air that's in the back of the speaker into a box that it cannot get to the front, and the front cannot get in the box? Voila, a speaker. And that's what's going on. Now, of course, speaker designers, the size of the box and all these things, these all have factors because as the cone goes in and out, it's pressurizing the air in the box, and there's effects from all this stuff. Some boxes have a porthole. Some of the speaker boxes have a porthole in them. They're called often it's a tuned resonant hole. There's a tube going back. There's fancy stuff going on to try to fiddle with the air at the back. I have an old radio around the corner, has a transmission line speaker. And what they do is they capture the air at the back. They actually have it, the speaker is sealed, and the air is conveyed down a zigzaggy tunnel that takes some time and comes out the bottom of this big radio. A radio like this one, big one. And it comes out with a certain delay, and they've tried to arrange it so the delay causes the wave to be in the same phase as the wave of the speaker. So in other words, the speaker's going out and this wave is going out. Of course, it's the wave from the previous wave coming out. Anyway, that's a little bit about speakers. I like to share that because I think it really opens your eyes to what you're trying to do with a speaker and a speaker box and a cabinet and all that kind of stuff. Okay, enough on the speaker, eh? Yeah, another thing I should warn you about, I have no trouble talking. I have no trouble talking. Okay, let's bring the radio up. Here it comes. Ooh, baby. Still in its cabinet there, look at that. This is a very, very cool radio. This guy does something most these radios don't do. Of course, I'm going to have to put this right back down on the ground because I can't take the radio out up here. Yeah, I just put it down. I'm not getting anywhere. Why did I put this up here anyway? You see? No script. No script. Okay, here comes a great big radio here. Now, one thing I didn't say about the speaker, you really can't operate this radio without the speaker. Because the speaker is part of the power supply. Some goodies here. Oh my gosh, look at that power cord. Wow. That is, I've never seen one quite like this. Yikes. Okay. I'll have to look that over very closely, but it's got lots of abrasions on the cloth covering. Oh my gosh, look at this. Well, that answers that question. Yeah, we're not going to use this cord. That's for sure. That's, well, it's an attempt. I'll say that much. All the tubes are here. Now the owner of this radio has, I believe they've owned it for a long time. I believe they've heard it operate. I believe they know it's a good radio. I don't though. Oh my gosh, it's a mile long power cord. Wow. So what makes this radio really cool is as you change bands from different bands, the lighting goes with it. So if you're on this band, this is all that lights up in there. The rest of it stays dark. So as you switch bands, the lights come on according to what band you're on. You can never get confused. Oh, yes you can. Because one of these radios I did, and this is one of the most mysterious things I've ever come across. These lights didn't light up the right band. And although these ones appear to have been pulled free, and there's lots of wire here, and you could pull these off and move them around. That radio, the wires were up tight, and they obviously had never been moved. So the only thing I could conclude with that radio, identical to this one, well, maybe not quite identical. This has an awful lot of push buttons. Wow. I had to conclude that it came out of the factory lighting the wrong band, and the owners never figured it out or didn't care about it for its entire life until it made it to my bench. And then, boy, that is a real head-scratching thing. It's hard to believe. It's hard to believe. How could they get the lights wrong? So that's something we'll watch with this one too, because it led to a huge confusion with the last radio, or one of these last radios. So the tuning string is completely off. Is it broken? Or is it just off? Well, it seems to be continuous. Well, it's very strange. That it would be dismounted like this. So there's definitely a process to putting a string back on a radio. I probably won't put this string back on since it's already off. I'll probably put a new string on. Okay, this radio has a magic eye. This is a neat little feature. It's hard to see, but it's visible right through here. And this is a tuning aid. So the radio, the thing about a magic eye is the eye operation draws no power from the radio, the operation part. If you put a little meter on a radio to indicate signal strength, the meter needs power to move up. This thing needs no power drawn to make the eye go like this. So that's why these are so attractive and found themselves in radios of this vintage. Because if you're going to use a regular indicating meter, then you must somehow supply the power to it, and that involves maybe more parts, more stages, more complication. One of these guys can be connected to pretty much any radio without impacting the radio's operation. Now, unfortunately, most of these eyes are worn out. They don't have a long life, and in most cases, the owner of the radio would play the radio, the eye gets weaker and weaker and weaker. He's not going to go spend $7 to get it replaced. He'll just put up without it, because you can still tune a radio without the magic eye. But the Magic Eye is a neat feature. So we'll have to see what happens with that. Now see, this connector, which is where the speaker goes, is cracked through here. This is a non-conductive plate and it's cracked. Probably cracked from extracting the speaker plug. Don't think that's of any real significance, but who knows. Has a phono input, that's interesting. These are the antenna and the ground inputs here for hooking up the antenna. This radio has no... Oh, wait a minute. More in the box here. What else we got in the box? Okay, I think this is just a spacer. These are the knobs. Yeah, I think this is just a spacer in the box. Okay, so we're at a loss here. We don't have the antenna. So most of these big radios have also, not most, but some have a specialized AM broadcast antenna, big loop antenna, down in the cabinet. Often you can rotate it. If this had one, it would have a plug for it. You would plug it in. It wouldn't use these terminals. And I see no such plug. Okay, no such plug. So what is going on here? So no plug for a AM loop antenna. It must just depend upon these. And we'll see that in the schematic when we get going. 3 ganged capacitor here. All 3 of these are the same size, but it says a little something about how the radio circuitry is arranged. And what caught my eye was this is not in the right place here. And the other side is underneath. The whole chassis is shoved this way. I don't know if that's really any kind of problem, but maybe I gotta shove it back before I try to lift it off. No shoving this back. So I want to take this bottom plate off, or pull the chassis out. Why don't we try pulling the chassis out if I can get a grip of it. We want to look underneath and see what's been done to this radio. It's all part of the initial inspection. Can I get this out? Plate. It's still screwed in a little bit. How can it be? These are the screws up here. Screws along here. No, this is on the outside here. It should be on the inside. So I think probably the owners, when they took this radio out, they unnecessarily released all these screws and probably pulled out the chassis and then saw the plate and then took the plate out afterwards. It's probably what happened. Oh, sure feels like it's screwed in. So I'm going to tip this radio up on its side. This is a problem with this radio because of this piece sticking out here. So it's a problematic radio while it's on this plate. Let me try lifting from the other side first here. So a good thing to grip onto, by the way, in these big old radios is right here. Grab this. This is the bulk of the weight right here. You get major control over the radio if you grab this guy. There we go. Okay, it's not attached at all. It weighs a ton. A ton. Now also, see, I'm still holding on to that transformer. I'm going to tip it up on its end like I have it now. You need to tip it with the big heavy transformer down, not up. In the air. Okay, it felt like the transformer's a little loose actually, just there. I don't know. There we go. Okay, now we check to see if there's anything ugly happening. Like it's leaning on these things. I have a bunch of shims here. There we are. Get the radio fairly stable. That's about as good as it's going to get. Okay, now we look underneath. And what do we find? Find this power cable all over the place again. I should just cut this right off. I should just cut this right off because it's not going to be used. Here we are. That'll save you from getting tangled up in the cord. Anyway. Okay. So, we see that no work has been done on this radio, or if work has been done, it's only a 1 or 2 parter that's been changed in here. I don't see any parts changed. So all these brownish capacitors here are you know, 99% for sure need to be replaced. All these guys here, there's quite a few. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, probably 15. There's probably 2 more in there I didn't see. There's one here. Probably 15 capacitors need to be changed out. Now, if you're doing radio repair, if you're at all like me, you make mistakes. And if I were to just start by changing these capacitors, change all 15 of them, I would probably make a couple mistakes in there. When I turn the radio on, it would not work. But it wouldn't not work because of the mistake I made. It would not work because there's 3 other problems also in this radio somewhere. And the combination of all this stuff, not working right, mistakes made with component replacement, could put this radio into a condition where you really can't figure it out without hours and hours of effort. So what I do to try to reduce that is, before I do any work, I try to get the radio operating. Now obviously that can't be done in some cases. You can look at the radio and go, no, I'm not going to plug that guy in. Not until 1, 2, or 3 things are done, and then I'll plug it in. Even though it may not work, even though it's still full of bad parts, even though there's a chance of something a little bit untoward happening if you plug in a radio full of bad parts, that's the process I like to take. I would not want to what's called shotgun all the capacitors, which is do them all at once, kapowie. Yeah, kapowie is what would happen. Been down that road. Every time I've gone down that road, when I've picked a radio with 7 capacitors, I go, well, I'll just do them all. 7 capacitors. I get into trouble. So I don't want that to happen. So here's a wire just hanging here. What is that all about? Start taking a closer look now that I've yapped myself out. Have a wire right here just hanging out here. That is definitely a question mark. Put a big question mark on that. Where's the other part of the wire? Maybe it's supposed to be down on here. But it's a stiff wire. It was up like this. Get caught under this plate and get chopped. That would be exciting. Potentially very exciting. You wouldn't tend to run a wire over top of this plate. If it had to get through, they would drill a hole and pass it through that way. So that's a real mystery. That's a good find. Uh-oh. Uh-oh, uh-oh, uh-oh. There's more cut wires. Uh-oh. Uh-oh, oh, 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 oh. So now I think I'm looking at a radio that somebody else, I mean, these wires didn't cut themselves. This isn't even soldered. This isn't even soldered in there. Okay, I'm not the first guy to look underneath this radio. Someone else has been here and done stuff. That's probably why the light wires the light bulb wires were all kind of splayed out and not tied down really tight. Is there anything else like that? Like all these wires look kind of pulled out and yanked a bit. So there's a couple things that can happen here when someone else works on a radio like this. One, they're a guy like me and they're making a repair, and maybe they did it and maybe they didn't. But you wouldn't expect anything too wild to be done. Then you got people who have ideas about wanting to make the radio do more than it was really intended to do. hook up an extra speaker, or who knows what might be in their heads, and they start doing stuff. They do their own creative things, whatever they might be, and then they're in the radio here. The last category, the one I've run into, is where people are trying to, a good example is get rid of the rectifier tube and put in some solid state diodes. Been there, done that myself. I had a really bad outcome doing that, so it's not something I've ever done again. Did it once, bad outcome. But other people have done that. I've had radios where that's been done, and I restored them back to the tube. Oddly enough, that's the route I chose to take. Why are these so? As I'm talking away, I am thinking, what could they have been doing here? Now this is the tube involved. So you can think of this as the front end antenna end of the radio, and the signal's just basically traveling along here through these tubes. Here it becomes audio, you can hear, and then it's out this is probably the rectifier tube here. What is this tube? This is almost certainly a pow. Number 80. Made by the Rogers Company. Look, if you're Canadian, hey, look at this. Rogers. That name come to mind right now? Rogers Cable, does that come to mind right now? Canada just had a country-wide blackout. And that's one of the reasons I wasn't doing a video yesterday. Was it yesterday? Country-wide blackout. It was the day before yesterday. No internet, no telephone, no texting, no email, and in some cases other systems like bank card systems not working, point of sale systems not working. Oh my gosh, Rogers Cable is a huge company in Canada, and they, along with two other large companies, are the service providers for Canadians like me. I get my TV, my phone, I get everything from them. And there one day there, I got nothing from them. Nothing at all. Boy, oh boy, oh boy. But Rogers is not a new company. Rogers used to make vacuum tubes. Rogers used to make radios. I don't think this is a Rogers radio. It isn't. This is not a Rogers radio. In fact, this is a... who made this? A Westinghouse, right? Canadian Westinghouse. Model 981, serial number, 85 watts. So that's why Rogers comes to mind, because yes, they once were a radio company and making tubes. They made a lot of tubes and other electronic stuff, and then they got into cable right at the very start of cable TV. Cable TV, an idea people scoffed at. I get it free off an antenna. Why do you want me to pay you to get it off a wire? Why would I ever do that? Well, now everybody pays them. I can't see any... Oh, here we are. It's a 5Y4. Okay, 5Y4 is a common tube. Rectifier tube. Well, we're up here. We're wondering about this tube. Let's just pull it out and take a look at it. What is it here? 6SA7. I think that's the mixer tube offhand. So I think we've got an RF tube boosting the antenna signal, mixer tube converting the frequency to the IF frequency, IF signal passing through this transformer, through this amplifier, through this transformer, then on to what is probably a 6SQ7. It's probably, this is the detector tube. What are all these guys doing here? I'm not sure. Here's the rather large filter capacitor right here. Right here. This is the guy that's probably not working well. Probably the radio would hum. So now what I'm thinking about in my head is, do I dare plug this in and turn it on? Obviously I'm not going to plug it in with this. Now, if you look at the bottom of this transformer, yeah, down here, come down here. So these transformers are often filled with a black tarry compound, and it leaks out. It leaks out the bottom and travels down these wires and makes them as stiff as can be, to the point where you cannot bend these wires anywhere down in here. You might not even be able to bend them out here. Now this one doesn't seem to have any black stuff leaking down, but nevertheless, like this wire is as stiff as can be. These aren't so bad. But the main point is, stiff or not, if you break the wire right down in here, you're in big trouble. You got big problems. So if you bend these things willy-nilly, the insulation is going to crack right open. You'll see the conductor ready to short onto this can or to other wires. You can't be fooling around with this. And very often the radios are done this way, where the power cord comes in. One wire goes to a fixed terminal on the switch. This is the on-off switch here, right here. And the other wire, I mean, they're both heading ultimately into this transformer. See, this wire goes into the transformer. But basically you have the two wires coming from the power system, the power wires, if you like, coming through. And they go straight into the transformer here, onto one winding, and that's it. So the, hydro, as we call it here in Ontario, or the electric power from the power system, is contained only in a winding here. Everything else is powered from the output of this transformer, and in a sense isolated away from the power system. So the reason I'm dwelling on this is I'm observing this to see that this is the case with this radio. I'm not surprised at all that it is, because it is. Get this bit of junk out of here. Now, has this power cord been changed out? You see what it looks like here? Do you remember what I cut off? How's that happen? Somehow so I think probably the original wire broke right in here, as they often do from flexing. And somebody came along and managed to make an attachment right to the ends here, just barely sticking out. This is exactly the same problem I was talking about here, only it's occurred right flush with the board here. No, don't try that. It should be replaced all the way back to here, which is why I'm talking so much about it, because I'm going to have to do it. So you see how in this arrangement, although this was fixed over here, this is just kind of floating here, and the connection is floating. It's not onto a terminal. This is really quite common in these radios. So, I'm lucky with this one. No big deal cutting this wire, stripping it back, attaching a new wire. It's not a big deal. But if this were rock solid stiff, yeah, it would be a big deal. We're going to get rid of more of it here, because it's just in the way. I can't forget which terminal it goes to. It's only one possibility. Okay, now we're down to that. Back to the question, do I dare plug this in? Do I dare plug this guy in? Or do we need to understand what's going on here? So, you know what I think is going on here? Yeah, can you see it? Let me put the close-up camera on it, because I think I figured out what's going on here. Okay, so this is up in the front end, or the RF end of the radio. So, wrong camera. What happened? This is the camera. Didn't I say I had trouble with it? Well, I'm going to stop because it's frozen. I'm going to stop and switch to a different camera for a moment here. Just take a moment. A moment in video time. Okay, let's try this. So we're going up into the RF area of the radio. And we see these two green wires about the same length, apparently not going anywhere, or not able to reach anywhere. But the thing that's, I think, worth noticing is look at the funny shape of them. Look at the funny bend to them. Let me just show you what I think this means. So this one isn't soldered. I think these wires should be like this. And that might be the end of it right there. And I may have just created a capacitor. a tiny 1 or 2 picofarad capacitor. So this kind of technique is commonly called a gimmick. And in the radio manufacturing process, you would put these 2 wires in. They would be quite a bit longer, maybe another inch or 2 longer. So they would come out to where my finger is here. And then you operate the radio, and under a certain specific test condition, you start trimming back. These wires are not connected. They're just close to each other and twisted. And you trim it back, trim it back, trim it back until you get the result you want in the factory. And you've actually created a compensatory capacitance that is compensating for something to do with the way the radio is wired. See, like it's maybe hard to believe, but every one of these wires is where it is because that's where it's got to be for the radio to operate. Now these look like they've all been tugged and pulled and jerked around. That's another bad sign. So that's something called lead dress. In a lower frequency radio like this, AM and shortwave radio, lead dress may not be a critical factor. But in a FM radio, this becomes super critical, where you run the wires. And to some degree what I think goes on is the manufacturers figure out, and this will be true of this radio too, they get their prototype models done, and they get one that's working really well. They go, that's the one. See where all the wires are? That's where they all got to be. Exactly where we've put them on this model. So all the builders in the factory will build them exactly the same. And they will run every wire exactly as the prototype was. And what's this? No, it's not. I thought I found another cut-off wire. So it can be somewhat sloppy in a radio like this one. This has got almost certainly the tone control here. Single wire all the way back to the terminal. I'm not sure. Why would they do this? They didn't bother with the terminal down here. Why did they bother with it up here? Oops. Another thing worth observing, and these old radios are all pretty much the same. The parts are soldered right to the chassis, which means the chassis forms part of the electrical circuit in the radio. It's just a big fat wire. A funny shaped big fat wire. So that doesn't look, well, I guess it does. I look with my own eyes. It looks, I'm going to say that doesn't look factory, but it does actually. This looks just a little newer than the rest of the parts in here. You can see this capacitor appears to be cracked open. Right in the shell appears to be cracked open. Maybe not. Yeah, funny things, especially when you're looking through a camera. How much more time have I got here? Strange. Okay, I don't know if I was just having a human experience. Have you ever looked at the hands of a clock? You look up at it and the clock appears to not be moving. The second hand appears to take extra long before it makes the first move. Then after that it seems normal. Have you ever done that? You look away, you look back, and the second hand seems to take 2 seconds to start moving. And you can do this over and over. Look away and look back. When you look at it, it seems stuck for 2 seconds. That's a human brain effect. And I think I just had it when I looked over at my computer screen here at the amount of time. Now, if someone's been rummaging around in here, there's a lot of light wires that can be damaged easily. And I know that because I've done that. So I'm looking at these coils with these light wires. Big hole in that one. So this, wow. Well, that's either a blowout, which I can't imagine that. Holy smokes, this does look broken, doesn't it? Let me get up closer. Let me just adjust the focus on my camera here. I'm operating it with a fixed focus because the automatic focus, it has a mind of its own. What is going on here? Let's look and see now. Oop. So you see the wire is actually not broken. It's bent down and going through a hole into the inside. There's another spot up here. So they're actually making connections to the coil inside the tube. And they just pull the wires down through a little hole there, so it's not damaged. Got the close-up camera going, we should make some use of it. I'm just looking for anything, that would say, plug this guy in and you will regret it. So soldering down to the chassis is a challenge, like this. And this looks very bad. So the challenge is the chassis is very large, piece of metal, and it's hard to heat it up enough. And so you see the solder has kind of a globby, it looks like it's built up and built up. It probably is built up. But this capacitor here, well, it's in there pretty solid. Doesn't look good, but could be the part I can see. Well, it won't matter anyway. I'm going to replace this capacitor eventually. It looks like something's been gnawing on it, chewing away at it. Okay. I'm looking for evidence of previous work, too. More evidence, I guess you should say, of previous work. Going to turn this guy on. Chances of it operating are really low. I'll give you that. Lots of these old radios I turn on and they actually operate, and sometimes not so bad, even with all these old parts. Now, now, how could it be that if my story is true about this, that it's not soldered down on the left side there? I can't get it in focus, but down there. How could it be the case? It was never soldered. So, this kind of thing, if you rap on the side of the radio, it will cause static, sound coming out of it. You can't have that not soldered. Wouldn't stop. You can see it moving in and out of that, even though it's out of focus. Wow. Okay, so this is a really odd thing. Now, this could be something else entirely. I could be completely wrong about it. It could be a twisted pair of wires heading somewhere in the radio, and somebody's cut them out. It could be. I'm not saying it is. Just saying it could be the case. Okay, let's go back to our other camera here. Turning this guy on or not without doing any work to it. There's various ways to do that, not only by limiting the amount of current that's available to the radio, but limiting how much of the radio is actually coming on. Like you can pull all the tubes out, pull out the rectifier tube, slowly sort of build it up. I generally plug the whole shebang in at once and restrict the total amount of power that's available. Now, why would we do that? Because the more the radio works, the more comfortable you can be in trying to fix the rest of it. If the radio's not working at all, and you change a couple parts, when you can't test the radio because it's not working at all, you can't tell if you've made a mistake. And the trick here to finding mistakes is you got the radio working fairly well, and then you make a few changes to it, then you play the radio and see what happened. The radio has to be working to a fair degree for that to work out. Let's just take off a chunk here. Well, it's very tempting to just plug this baby in. We'd have to have the speaker plugged in. Can operate it without the speaker. Most of these radios, the speaker is also a switch. There's a jumper associated with it, and when the speaker is not plugged in, this jumper is missing, and so power is very, very restricted in the radio. And that's to prevent some bad things from happening. So no speaker, no chance. I suppose you could get a feel for if the speaker's good too, because if the speaker is shot, what are you doing? The speaker's shot. I have two nice radios similar to this, like big old floor standing radios out in my garage waiting for me to do something with them. Neither one has a speaker. What am I supposed to do with them? I don't know. Now you could probably get away with swapping speakers quite a bit as long as you get the wiring right. What's this screw here? Oh, so there's a screw hidden in there. This is put in and screwed in. And looks like somebody took it out without taking the nut off the end of the screw here. Looks like there's no nut there now. Yank it out and broke this piece. Now, you know what? I could do the same thing because I've never seen one that's screwed in, locked in. Is that screw going to cause a problem? I don't think so. So these pins are arranged in a pattern. You can only plug this in one way, the correct way. One way. There we go. Well, we have a speaker now, and we haven't seen anything that would tell me it's just totally stupid to try and operate this radio. It's only partly stupid. Partly stupid's good for me. Now I've got a cheater cord here somewhere which I have to find. So here it is. My cheater cord. Now I mentioned I'm going to plug this in and restrict the power to it. There's a number of ways of doing that. The high-tech way is to use this kind of device here. But you know, I don't. I always thought I was really missing something when I didn't have one of those. Now I have one, but I don't use it because I prefer another way called a dim bulb system. It's nothing complicated about it at all. It's just the power on the way to coming to the radio is put through some light bulbs, incandescent light bulbs on the way there. So in series. So the radio's in series with these light bulbs. You turn the power on. At the power start you got the full 120 volts. But with the light bulbs in there, much less voltage gets to the radio. And it has to do with how much power the radio draws and things like that. The beauty of this is because you're using light bulbs, they glow. And based on the way they glow, you can make deductions about the condition of the radio. So for instance, when I hook this guy up, I just follow my own safety practices here. I'm getting pretty close to turning this thing on. Yeah. Forgot what I was going to say. Well, that's another thing that happens. Yeah, I also make claims. I'm going to do this, I'm going to do that to this radio, this, that, the other thing, and then I never do them. Because I just carry on. Yeah, I really lost my train of thought there. Do you know what time it is? Coffee break time. I'm going to take a coffee break, give me a chance to rethink the craziness of plugging this in, and then we'll do something. Okay, a couple of sips of coffee, and yeah, I'm ready to plug this guy in. So, let's just practice a little bit. Practice. Okay, radio's off. That's the practice right there. Can't tune it. Band change. We may want to change the band, and we want to know what band we're starting on here. So I don't have the cabinet to look at, but you know, most radios all the way this way is going to be AM. That's where I'd like to start. AM, there's no antenna. Some radios without an antenna are so quiet that you don't even know they've come on. So we're going to stick a pseudo antenna on here. Okay, so I can look in the back and see which is ground and which is not. So this terminal is grounded solidly right here. So this is the antenna, the other one. Okay. This ultimately goes to an outdoor antenna, but at the moment this is just a long lead in my house, so it's not exactly the best thing either. Let me throw this over top here like this. Okay. Volume at the bottom. Always good to know where the volume is. First thing we're going to do is apply power and see what happens with the switch off. And of course, you know, ideally nothing will happen at all. Now, the dim lights. Did I finish explaining the dim lights? The beauty of the dim lights, they're right here, is that those two light bulbs are in parallel, and I screw them in depending upon how much restriction I want. Right now, this is the only bulb that's in. This one is loose. So all the power will go through that one light bulb. Make sure that one light bulb. That'll severely restrict the amount of power that can get here. If this thing is short-circuited in some way or has something really terrible wrong with it, the light will come on fully bright, and that'll be my indication that this is not going well. If things are going well, what will happen is the light will come on quite bright, but it'll begin to dull down a little bit. It's going to dull down because the current draw on the radio is going down as the heaters heat up in the tubes. The heaters are cold, they are low resistance, they draw more power. So the heaters will heat up, the power will go down. Once the heaters heat up enough, the tubes begin to conduct. Once the tubes are ready to operate. And also the rectifier tube in particular, once that one starts operating, more current is drawn by the radio. So the light, which came on, dulled down, will start going up again. So good operation, this is what we see. You're going to watch the lights. What we're going to see is light on, going down, and then a light coming back up, and the speaker coming to life. What we're more likely to get is I'll put power on this thing and it's going to hum like a son of a gun. That's the end of that. That's more likely what's going to happen. Yeah, so I'd like you to keep an eye on these guys here. Now, I can bypass these lights and send full power by operating this switch here. This switch kind of turns the power on to all this stuff. This switch decides if it's going to go through the light bulbs or straight to the project. Power is fed to this guy here. This is an interesting device. It will tell me the voltage and some other factors about the radio, the amount of power it's drawing, things like that, if I'm interested. So I can look at this and see the voltage right on the outlet, which is right where the radio is going to go. You notice this is a 3-prong plug, and the prong is just sticking out here. It's not going anywhere. This is a 2-wire extension cord coming out of my power thing here, my power system, I guess. What you can't see is that there's an isolation transformer. Not just this guy. There's another one behind it all. So in the same way that the electricity from the power system is isolated away from the rest of the radio by the fact that there's a transformer, the same thing's happening in my shop with a big honking transformer you can't see. So that means this ground here is nothing. Wouldn't mean anything anyway, even if this was a 3-wire, and there would just be no way back to to the green wire ground system, and ultimately back to the neutral, ultimately, of the incoming power system. Anybody follow that? I sort of followed it. Okay, switch is off. We're going to apply power through the light bulbs. Nothing should happen. Well, I heard a cat meow. I don't know if you heard that. This is 116.2 volts. That's good. Now, I'm going to turn the power off. We're going to turn the switch on. I'm going to turn this on nervously, keep my eye peeled on those lights, and make a judgment within a second or two as to whether this is working out. Here we go. 1 second. 2 seconds. It's going down. It's very, very restricted power. I bet you this guy, 37 volts. I'm surprised this thing will even work. Here, my poor cat. He's yelling, hello, hello. I'm going to give that just a few minutes. So the indication here, that's not full brightness. In the camera, you have trouble seeing what's going on, but I can tell that's not full brightness. So nothing bad happening here. No funny sounds, no smoke, no flames, nothing. Just a cat meowing. We're going to up the ante here. I'm going to screw in the other light bulb. That's cool. My wife made that for me in 1983. I'm going to screw in the other light bulb. That's going to jump the voltage up. It's 45 volts now. This is nowhere near enough to operate a set like this. But no indication we're in the danger zone. Here we go. Okay, now we're going to jump the voltage up to 88. Oh, speaker. Not the best sound. The bulbs are indicating there's no bad short circuit in here. Well, okay, we don't have to keep our eye on those lights anymore. I can keep my eye on them. We don't have to. What are we hearing? Is the radio actually receiving something more than just noise? We'll operate the band switch. This will tell us a fair bit too. So just doing that tells me a good deal of the radio is operating. Where'd all the crackling go? Now if you watch up behind the panel, you'll see the light move. Can you see that? Maybe I can hold my camera this way. I'll turn this way. Hard to see, but the bottom band is lit right now. I'm going to turn the band switch, and you can see the light moving down there. Getting better all the time. Tone control works. Volume control, got some problems there. You can't turn it down. Once again, think we're on the broadcast band. I've got to tune this radio with a broken string. So I can tune it this way. What do we get? Here we go. Oh, look at that. If you're wondering what I'm doing with my hand, I cannot touch the radio and I'm moving this wheel. I should not touch the radio and anything else at the same time until I've done some more testing on it, just in case there's voltage on here. Now, because I'm using an isolation transformer, I cannot get a shock to earth. That's the theory. Here we are. Okay, fixed. It's done. Ready to go home. So that sound is a sound I hear all the time in my shop on AM radios. Look at that. There's a station there. We're operating with only 85 volts. And I'm going to go turn the antenna on. You just keep an eye on the radio. I'll be gone for 22 seconds. Anything happen? Doesn't sound like it, does it? I'm doing the sniff test. Smells like an old radio heating up. Okay, we're going to cut it. Okay, so first of all, it's 2 thumbs up. The radio is largely working. What this means is, as I go through making changes, changing parts, and that, I should be able to detect the change in the output of the radio. It also tells me that the major parts are working. The IF transformers, the power supply transformer, all the tubes appear to be working. They may not be fully at full strength, but they're enough to work. So it's actually a very, very, very good result so far. And that's it for today. That's as far as I'm going. A few things to think about as I plan my approach on this, but I think it's pretty straightforward from here. That's what I think now. Anyway, so thanks a lot for watching. I hope you enjoyed that. And we'll get busy on this radio, fixing it up now. See ya.